This video is for the first 6 sections on volume for the quarter 2 credit recovery assignment. The first one is on a prism. You want to remember that for all of these volume questions, you have formulas, which of course you can Google, but just as a reminder, volume for any prism is area of the base, that's what the capital B stands for, times height. So when it's a rectangular prism, that B turns into length times width of the area of that rectangle, and then times height of the whole prism. If it's a triangular prism, it's 1/2 length times width times height. Again, you can Google them. So this is really easy. You're just going to simply multiply 6 times 10 times 2. So that's going to be 120 inches squared. For volume of a cylinder, again, you need your formula. So V equals pi r squared h, r being the radius. So you have to make sure that you have the radius. So in this case, they're giving us a cylinder with a height of 12. So there's my h, base radius of 6. In this case, I have everything that I need. I want to remind you that you very well might need to, like if they give you diameter, divide by 2, right? You got to pay attention to what you're given. But once you have all the information you need, remember pi is a button on a calculator, so you would use pi. You would type all of that right into your calculator, which I am doing as we speak. And it's going to give you a long decimal. So 1,357.16802. They want it to the nearest tenths. So this would be 1,357.2 centimeters cubed. I think I wrote inches squared on the last one. That was silly of me. That should have been inches cubed. All right. Now we're dealing with a cone. The volume of a cone is V equals 1/3 pi r squared h. Again, you need your volume formulas. So we have a height. And this time they gave us a circumference. So this one is where it gets a little bit trickier. You have to do some side work. So there's a circumference formula, again, on that formula sheet that says C equals pi times diameter. So I would substitute 16.9 in for the circumference. I would then divide by pi on both sides because I have to solve for the diameter in this case. So 16.9 divided by pi is again going to be a very long decimal. I'm going to go to 4 decimal places just to maintain accuracy, and that's equal to the diameter. Remember, I need the radius in my formula. So I'm going to go over here and do V equals 1/3 pi. The radius is half of the diameter, so I'm going to take this number and divide it by 2. So that long decimal, when I divide it by 2, is approximately 2.6897 squared, and then times the height, which is 9. I'm going to type that big long thing into my calculator. So I am doing that as we speak. And it gives me my overall volume of 68.2 when I round it centimeters cubed. Again, you're just following the formula, but you might have to do a little bit extra work. We have another right circular cone, so V equals 1/3 pi r squared h again. And for this one, they're giving us a height and a radius. So this one, I can just go right ahead. I don't have to do any of that side work. I can just substitute all of the values where they go and then type that into a calculator, which again I'm doing right now. Desmos, as a reminder, is the one that you would want to use, not your phone's calculator unless you understand how to use the pi button on it. So this is 980.591598 to the nearest tenth is going to be 980.6 inches cubed. Delta Math also has a calculator, and you could use that. You just have to make sure you're using the pi button. Okay, the next example is volume of a pyramid. So all pyramids have the same formula, and that's 1/3 area of the base times height. If this is a rectangle, that turns into length times width. If it's a triangle, that turns into 1/2 length times width. So you again can look up these formulas. Where the side length of the base is 8.3, they told me that it has a square base. So that's going to be like length times width. So I know that my volume is going to be 1/3 length times width times height. In the case of a square, length and width are the same number. So I'm just going to substitute that 8.3 in for both the length and the width. My height is 7.3, and I'm just typing that into the calculator. So 1/3, and then times 8.3 times 8.3 times 7.3. And they want us to round to the nearest tenth. So when I do that, I'm going to end up with a 167.6 inches cubed as my final answer. A sphere is going to be V equals 4/3 pi r cubed. Again, this is just the formula for it. I need the radius. I have a diameter. So remember 9.3, oops, sorry, that got a little messy. 9.3 divided by 2 is going to give me my radius, which is 4.65. So now that I have that, I can substitute it in. 4/3 pi r cubed. This entire thing goes into the calculator, which I'm doing now, and I get 421.16 yada yada yada, nearest tenth, so 421.2 meters cubed. As a quick reminder, if it asks for the volume of a hemisphere is half of a sphere. The last section is on density, and density you're always going to start by finding the volume of the shape and then multiplying it by the other piece of information, which is usually the density information, so how much it weighs per measurement. So a shipping container is in the shape of a right rectangular prism, so that's going to be length times width times height for the volume. I'm going to substitute the length of 3.5, the width of 11.5, and the height of 8 into my formula. So I'm going to find the volume. It's then telling us that it's completely filled with the contents and they weigh 0.33 pounds per cubic feet. The reason I'm finding the volume is because I'll have my cubic feet at that point. So I'm going to first get the volume, because again, step one is finding the volume of whatever shape they're talking about. So that's 322 in this case. So then to deal with this part right here, I'm simply going to multiply the 0.33 pounds per cubic foot times that cubic foot amount that I have. So I multiply the volume by what they give me for the density, and I end up with 26 here. They want it to the nearest pound, so 106 pounds would be my final answer. One more example for density, a hemispherical tank. So I know I need to start with this formula, which is a sphere, but because it's a hemisphere, I need to divide it by 2. I'm then going to use that and multiply it by how much it weighs per cubic foot. So I'm given a diameter of 15. That means my radius is 7.5, because again, I have to divide my diameter in 2. So I have the volume is equal to 4/3 pi 7.5 cubed divided by 2. I'm going to type all of that into my calculator, which is going to take a second, but that's what I'm doing right now. I'm typing the entire thing into my calculator, and it's going to give me a value of 883.5729. I'm going to then multiply that by the 62.4, which is the weight per cubic foot. So when I do that, I end up with my final answer. They want it to the nearest pound. So it's 55,135 pounds when I round it to the nearest pound. So that would be my final answer. So again, step one, find the volume. Step two, multiply it by whatever the density is. And that is how you do the first few sections of quarter 2 credit recovery.